The Pavilion data architecture, shattering performance expectations. Our hyperparallel architecture delivers impressive, best-in-class performance numbers, whether it's block, file, or object. So what does the Pavilion architecture enable, and how does it compare to the competition? Remember, I talked about predictable, scalable, consistent high performance. Now, whether that's block, file, or objects, since our platform supports all of the above in any combination. Let's start with our block performance. Remember, in each one of these, we're talking about a box that is 4 rack units and 1 petabyte usable storage. In other words, protected storage in our world RAID sticks. As we look and drill down to each one of these, block, file, and objects, let's start with block. Our performance is 120 gigabytes per second read, 90 gigabytes per second write, 20 million IOPs and 5 million IOPs, 100 microseconds read, 25 microseconds write. Well, that sounds impressive. Let's look at that to the competition. And when I refer to this competition, these are all industry published numbers based on their websites of their performance. The first one is 15 million IOPs, 350 gigabytes per second read, and that's a Power Max with 8 engines. Very impressive, but that takes 80 rack units to deliver that. We do 20 million IOPs and almost half that performance in read in 4 rack units. The next one is 11.4 million IOPs and 300 gigabytes per second read. That's a cluster of NetApp AF 800s, and it's a cluster of 12 of them. That's 48 rack units. As we look into the next one, this is Pure Storage, and they don't publish their IOPs or their gigabytes per second read, but on their website they do publish their latency of 150 microseconds to 1 millisecond. Well, we're 25 microseconds to 100 milliseconds. And look at the throughput. Through different research, through articles, you can glean that as 18 gigabytes per second read. Let's say I'm off and we double that, 36 gigabytes per second read. We're 120 gigabytes per second read, and that is with their all-flash, which, depending on how you configure it, 6 rack units to 9 rack units to get the same capacity. So when we look at the block performance of Pavilion in our 4 rack unit and 1 petabyte, compare that to the competition on a per rack unit basis. We're anywhere from 7 to 50 times the IOPs, the competition, 7 to 10 times the throughput, 2 to 7 times the capacity. It doesn't stop at block. That same box can do file. And we look at our impressive file numbers, or NFS, 90 gigabytes per second, 56 gigabytes per second write. Remember, 4U form factor, 1 petabyte usable. As we compare that to the competition, the first one is Pure FlashBlade, where they publish 15 gigabytes a second read. That's in that same 4RU form factor, but half the capacity, and their write performance is not published, but through gleaning it and researching about 4.5. But if you look at that, that's substantially lower than Pavilion. The next one is Isilon, 15 gigabytes per second read. In a 4U form factor, they don't publish the write. Someone out doing a lot of advertisement is Vast, 20 gigabytes per second read, don't publish the write. That's in a form factor of anything from their 2U enclosure, that's guaranteed, to have at least 2 of their servers, so I'll call it a 6U form factor. So when you normalize that per rack unit in the NFS world, we're 6 to 7 times the read performance, 12 times the write, and 1 to 2 times the capacity. Again, doesn't stop at block and file. Now let's move to object. Read performance, 80 gigabytes per second, write 35 gigabytes per second. Look at the competition. First one is Pure Storage, about 14 gigabytes per second read. In the similar form factor, half the capacity. The next one over is MinIO, which, by the way, is a software that we leverage in our platform. And in that same environment, MinIO says they do 183 gigabytes per second read, 171 write. What's published is that's on their AWS infrastructure and takes 32 AWS extra large nodes to deliver that. And I was pretty generous. Let's assume those AWS extra large nodes are 1U. That would mean they're 32 rack units. Pretty high probability that that's 64 rack units. We're doing a little less than half that in 4 rack units. Next one's getting a lot of press because, as they say, it's 1 terabit per second write. This is OpenIO. 1 terabyte per second write means 171 gigabytes per second write. To deliver that requires 704 rack units. It's 352 physical servers to deliver that performance. We do a little less than half of that in read in 4 rack units. So what we do is a per rack unit basis. We're anywhere from 3.5 to almost 6x the read, almost 9 times the write, and 1 to 2 times the capacity. So as we look at performance and scale, it matters whether it's block, file, or object, or any combination in between. We can stand up to the competition and deliver those results that enable flexibility. To learn more about us, check out our website at pavilion.io, or of course, call or email us. Thank you.